I'm going to hit the record button. There it is. Okie doke. I am going to minimize this and move it up out of the way. And then I'm going to start pressing buttons here.
I'm going to be doing the same thing in a minute, I'm sure.
Yeah. Yeah. It always takes a weird little kind of kick in the pants to get this thing working. Well, welcome to another Grand Canyon Historical Society virtual outing. We're thrilled that you could join us tonight. Hey, are you a member? You know, dues to this organization are only $35 a year. Think about it. That's 3 cups of designer coffee at these prices today. This is an all-volunteer organization. Nobody gets paid to do what we do, like volunteer to do these wonderful virtual outings. So please donate if you like what you see. As a member, you will get 4 publications every year, and these publications are chocked full of the most obscure history about Grand Canyon, the Grand Canyon region. I mean, just stuff you're just not going to find on the internet. Until a year or two later, this stuff does appear on the internet. But really cool. Actually, there are over 400, now there's over 500 Grand Canyon oral histories on the website grandcanyonhistory.org, including a wonderful oral history series with tonight's speaker, Nancy Muleady-Mecham. But there's all kinds of other things there. There are some incredible photographs, a miscellaneous Grand Canyon history, virtual tours, all the virtual outings that our presenters allowed us to record. There's some wonderful stuff there. And you too can be a member. It's only $35 a year. Go to grandcanyonhistory.org and go to membership, and you'll be on your way. Do you have a presentation you'd like to give? Please send an email to us. There's the email, outings@grandcanyonhistory.org. That would be great. We'd love to hear from you. We are booked out through February of next year, but we're looking for people after that. Speaking of looking ahead, let's do a little scouting. Next month, Tuesday, November 14th, archaeologist Ralph R.E. Burillo is going to present The Anthropology of Paleontology, a brief look at indigenous depictions of the fossil record in the greater Grand Canyon region. And again, that's going to be here at 6 o'clock, Tuesday, November 14th, 2023. Tonight's speaker is Nancy Muleady-Mecham, and Nancy's going to present the Quaternary Fauna of Grand Canyon. Nancy Muleady-Mecham served as a National Park Ranger naturalist and protection ranger. Now, wait a minute, let's look at that. She was an interpretive ranger, a naturalist, park naturalist, and a protection ranger. There are very few law enforcement rangers that love interpretation and to be a naturalist. And Nancy combined both of those skills in a most incredible way at Grand Canyon National Park for 18 years. Her PhD dissertation explored the natural history of fire in the greater Grand Canyon ecosystem. During her master's degree in biology and paleontology, she focused on Quaternary paleontology at Northern Arizona University, publishing her research urine analysis of Neotoma, pack rat, amber rat. And if you don't know what that means, what it means is little pack rats pee on stuff. And boy, there is interesting information about the deposits they leave behind. I mean, it's just amazing stuff. Nancy is the author of several books, and she has recently been appointed by the Secretary of the Interior to the Bureau of Land Management's Central California Resource Advisory Council, and she was appointed for a second 3-year position just this. She lives in the Sierra Nevada with her family, and this was her incredible dog, Kate, a 3-legged wonder dog, and it is an incredible honor to present to you tonight Nancy Muleady-Mecham. I'm going to stop my share. Nancy, you're going to start your share, and you're on your way. Thank you.
Thanks for that incredible introduction, Tom. That's wonderful. Let me get to here. We will share this, even though I don't see a picture. That's interesting. We'll see what shows up. There it is.
Just thinking about it.
And folks, we're going to keep your questions to the end. And I'd appreciate it if, when it comes to that, that you unmute yourself so that you can ask questions, because I won't be looking at chat during the program, just so you knows. Okay, one more thing we're going to be doing here. Okay, and from beginning, here we go. Are we good, Tom?
We're good. There it is. Thank you.
All right, everybody. Well, welcome. And reconstruction of Quaternary Grand Canyon. Years ago, when I was working on my PhD at Northern Arizona University, I had always loved paleontology since Tom mentioned my work at my master's. And so I was able to work with some incredible top-line paleontologists. And the first thing I did is I learned how to say Quaternary, which I used to say Quaternary. And so I felt like I was part of the in crowd once I learned to say that. This presentation tonight, though, is going to talk about several things, and you'll see what appears to be repeat of some information, but that's where I'm taking some of the introductory information and focusing it down to where we're going to emphasize it. We're going to talk about the modern Grand Canyon, the Quaternary. What is proxy dating? We'll talk about that as well. And then we'll put it all together to reconstruct and then come up with some conclusions. Now, I feel like I'm preaching to the choir when I talk about the modern Grand Canyon and just how incredible it is. It's a beautiful place, and there's absolutely not a single picture on this planet that does it justice. For those of you who may not know, it starts all the way up in Colorado in the Green River and joins the Colorado and comes on through, coming out into the delta of between the Sonoran Desert and the Mojave Desert, Arizona and California. And one of the things that we have down there are fossils all the way from Colorado. We don't have them accumulating anymore because of the dams that are built between here and there, but that's how far the water would carry fossils all the way down to the Gulf of California. So at 277 miles long, just through the Grand Canyon, it's a pretty special place. And the special place is going to look different depending upon where you are. From the rim, you're going to see some gorgeous things, whether it's summer or winter. And I remember working at the canyon when the fog would fill it, and it would just be gorgeous. And the little tops of the little buttes would show up, and I think was gorgeous, but the people who came to see the canyon would be sad. I also have to interject here that I have a parakeet, a budgerigar named Dingle, and he loves to talk when I talk. So there's not much I can do to shut him up. So he's going to be background here. He's going to be my sous chef on this. And then we look out at the Tonto platform, just that beautiful flat area at the base of the buttes, down to the platform itself. You see, it doesn't quite look like the rim itself. It's a whole different environment. And then getting on the river, looking up to the top itself, again, very different. So if we look at a geologic time chart, and we're looking at, Cenozoic, Mesozoic, Paleozoic, Precambrian, and all that stuff, the Quaternary is actually one of the more recent areas. In fact, it is the most recent area, divided up into different sections itself. We have the Holocene, which we are in right now, and the Pleistocene, which we just left. Now, some people contend, and I kind of look at that as well, if the Pleistocene is the Ice Age, if we still have glaciers on the planet, as small as they might be, then we're still part of the Pleistocene. To give you more, Holocene means the recent time, and there's people who want to put yet another layer in there, another epoch called the Anthropocene, meaning the time that mankind has affected what is happening on planet Earth. And you'll find that geologic time looks for things that happen to kind of indicate what the different epoch or era or stage that we happen to be in. If you look at the bottom of this time unit, modern, we're here thousands of years ago. Then we have the Holocene that we mentioned. And then just before that, we have something called the Wisconsin. And I want to keep the Wisconsin in mind because we're going to be referring to that, a time when things were very different and how they changed into the Holocene and how we are changing things right now. To look at different things like that, we use all kinds of data. And this is carbon years before the present. And I get paid by the syllable, so I can say hypsothermal and altothermal and all these other things like that. But what I wanted you to know is that we use many different ways to look at the different stratigraphic layers to date them and to figure out where we are in geologic time. So what are these sources of proxy data? And if you're not there actually counting it, you need something else to tell you what it was. And that's what proxy data means. Use historical records, tree rings, which is dendrochronology, lake sediments, which is really cool because you can go down and get cores that come up. And in those cores would be pollen from thousands of years ago. The study of pollen is palynology. Corals, ice cores, speleothems, which are things that make up the inside of caves, stalactites and stalagmites, paleosoils, ancient soils, geomorphic features, things that have been formed over time, marine sediments. All of these are things that allow us to date when something may or may not have happened. When you look at the Grand Canyon itself, you look at the very tip top and you can see that we stop at the Kaibab limestone, Kaibab, Torowik, Coconino, Hermit, Supai, on and on and on. So 250 million years are missing from the top of the area of the Grand Canyon. If you go to the east of us, well, there, us being at the Grand Canyon, then we've got many of those layers there. So the late Cenozoic is where we actually have the rock strata. And the Quaternary is not present in the rock strata. So we have to look elsewhere in the canyon for the evidence to reconstruct the Quaternary of the Grand Canyon. And we're going to look at climate, vegetation, fauna. I'm going to put it all together and a little brief talk about the human presence. The topography is also pretty important. And what's weather versus climate? Weather is what happens daily. You know, it's going to rain today, it's going to mist today, but climate is the weather over a long period of time. And when you take a look at the Grand Canyon's climate today, you can see that the North Rim, being 1,500 feet higher than the South Rim, has about twice as much average precipitation. Now, keep in mind what an average is. An average where a man is standing with his head in a hot oven and his feet in a bucket of cold water, but on average, he's fine. So we don't often get that 60 inches of rain, but, you know, we might get, 40, 50, and then the next year get 120. So it's going to vary, but on average, that's what we're looking at. So climate over time from the North Rim to the South Rim and all the way down to Phantom Ranch is a real change in climate from 1,200 feet to 9,100 feet. So things change in that different environment. And because of that, we will have different plant communities. Starting at 9,100 feet, 8,000 feet is the boreal zone, and boreal means northern zone. So it reminds people of things in the northern latitudes: spruce, fir, aspen, mountain grasses. Let's go a little bit lower, 8,000 to 7,000 feet. 7,000 feet is the elevation of the South Rim. We have a transition zone between plant communities: ponderosa pine, gamble oak. We've got aspen and white fir there. Also, if you go right below the rim of the South Rim, on the north-facing slope while you're going down Bright Angel Trail, you're going to have some Douglas fir there, which are not supposed to be there as a community, but it is simulating a higher, colder elevation. So they do just fine right there if they happen to have their seeds show up. So this is not a hard and fast transition zone that we have here. And then from 7,500 all the way down to 4,000, the upper Sonora zone. We've got your PJ and the pinyon juniper, which you're going to see on the South Rim as well, mountain scrub, and chaparral. And chaparral, I wanted to point out to you, is a fire-adapted ecosystems. And I want to say one thing right now is we do have fires in the Grand Canyon. That was one of the things I studied, well, that for my PhD. And when people would come to the Grand Canyon and they would lament the smoke from the fires in the canyon and how dim the view was, one of the things I have to say is that's the way it's supposed to be. Natural lightning-started fires or even volcanic started fires happen all the time. And because we suppress them, we're used to a nice, clear view of the Grand Canyon. But, for thousands of years and millennia of years and millions of years, fire pretty much obscured the view of the Grand Canyon from the North or the South Rim. Going down 4,000 to 1,200 feet is the lower Sonora zone. Hot desert shrubs, acacia, mesquite, creosotes, and cactus all abound here. But again, you're also going to have something else going in the middle, and that's your riparian habitat with your cottonwoods and things as well. So with a variety of different communities of plants, there was a incredible biologist by the name of C. Hart Merriam, and he noticed the difference in the changes from 8,000 feet all the way down here at the Grand Canyon to 2,000 feet. And he noticed that the change of these plant communities often simulated the latitudinal changes. So if you went from, the equator all the way up to the Arctic, it would in part, take a look at this, and he used part of the San Francisco peaks to take a look at some of the plant communities he was using there. But climate has always been the single most profound influence on the Grand Canyon. And you got to understand that we do have things that happen in the Grand Canyon. People don't know how to read the weather, and they'll go up a slot canyon and you'll never hear from them again. So you really have to pay attention to the weather around. But we have incredible fauna here that lives within the flora here, from the cactus down to the sheep and all the way around. And one of the things that happens here in the canyon is the carving of by water, and it's coming down from rain. And one of the things rain does when it comes through our atmosphere is it picks up CO2. And when CO2 is dissolved in water, it becomes carbonic acid, a weak acid, but a whack acid nonetheless. When that hits that limestone, that Kaibab limestone and other limestones that are here, it's going to start to dissolve it, kind of like putting lemon juice on top of a piece of shell. It'll start to bubble, and over time, you're going to start to form caves. So this is the beginning of finding our Quaternary fauna here by looking at the caves that we're going to be finding here. And within these caves, we're going to have paleo-environmental warehouses. I love that description of pack rat middens. And pack rats are small rodents. They are right there, you can see it, a small rat. And there are many different species of Neotoma, which is their genus name. We have all these different specific ones here, and they have different ranges, but almost every single of the ones listed here are somewhere in the Grand Canyon. And pack rat middens are known to pick up things and go back and make a little house for it. And the house has got all kinds of things in it. It's got a den, it's got a place to go pee, it's got a place to store food, it's got a place for the kids. If you ever had a chance to dissect through one of these, it's just remarkable. And depending upon the range of elevation, you're going to have a different pack rat species and associated vegetational zone. And to build these middens, they cut off vegetation, bring it back, and as Tom alluded to, once they start building up this mound, then they pee on it to glue together, and the pee is the glue. And when I was taking Quaternary science with Ken Cole and Jim Mead at Northern Arizona University, we went to Walnut Canyon and we found some of these 6-inch middens and 4-inch middens, and they were just remarkable. And then I started to find the middens that Ken told me about in the Grand Canyon. There's a very famous one on Horseshoe Mesa called Cave of the Domes, and I'm standing on it. This is thousands of years old, added to by pack rat after pack rat. That is one gigantic midden, let me tell you. And you can imagine, if it's been there for thousands of years, the things that we find in there. One of the most tedious tasks I had in the laboratory was taking the tiny little pieces of foliage, part of a needle, part of a seed, some pollen, and identifying them by their cross sections. That's a limber pine. We don't have limber pine now, but we did at one time. So they are a paleontological warehouse for sure. We do have 53 middens that we know of where we were studying in between 34,000 and 1,100 years before the present. And then from 21,000 to 15,800, we had full glacial depressions, meaning we had evidence that glaciers had been in the area. And the displacements of the plant communities. We had spruce that changed 500 meters, which is about 1,500 feet. Limber pine, which is the Flexidus, the Pseudotsuga, which is the Douglas fir, and Abies or white fir, juniper, and saltbush as well. So all of them are displaced compared to where they are today. So telling us that the whole climate was different many, many years ago. And of course, in the modern, dominants began to evade, and you'll learn that they didn't exactly replace what was here before. That's kind of a misnomer, and one of the wonderful things that Ken Cole came up that I want to pass on to you as well. So the pack rats themselves can climb on all of these cactus and everything. And one of the things that I was curious about, being also a physiologist and studying pathology, was, okay, I know what the plants are, I know what the seeds are and stuff. What is the urine, the paleo urine or the ancient urine of these pack rats that have glued it together show us? And the name for the ancient urine is called amber rat or yellow rat. And so amber rat paleo urine, it's not exactly amber in color, but what I did is I took a paleo urine from a variety of different sources and rehydrated it. And you could see that I had Walnut Canyon, Rampart Cave, some from Kings Canyon, Nankoweap, Picacho. I even have Hyrax, which is an animal from the Wadi Sana in the Mideast, had a control, and then human urine. And yes, that was mine. And so we took and did basic urinalysis of it, as you would if you went to go have a urinalysis test in a hospital or a clinic or something. And I got all kinds of results. It was amazing. It just wasn't dirt. It was, not to make you look at this too much, but if you take a look at it, this is the things we looked at: color, clarity, protein, pH, glucose, specific gravity. What did we find in here? Leukocyte esterase, by the way, in human beings tells you whether you have a presence of an inflammation secondary to maybe a bacterial infection. And so this is what I had in all of the middens. And you can see I had examples of everything. When we take a look at it: color, clarity, protein, pH, glucose, ketones, which are byproducts of breaking down of fats that are released by the liver, bilirubin, again, another liver indicator, hemoglobin, blood in the urine, nitrates, and leukocyte esterase. Now, it's interesting to talk about hemoglobin without getting too technical, because if you're spilling sugars, as we say, or spilling blood in your urine in a human being, that's not a good thing. But these animals also pee something called oxalic acid, and it can be very irritating. So it wasn't too big a surprise to see perhaps some hemoglobin. So what did we find? We found glucose. So they're spilling glucose, something you don't expect to have in a human urine. We also found the hemoglobin that I mentioned. Nitrites, the presence of proteins, which we see here. Cas, this was the most remarkable thing that I found. Looking under not a dissection, but a compound microscope, we found casts of the loop of Henle. We found casts of the physiology or the anatomy of the kidney itself in the paleo-urine analysis. It was remarkable. 1,000-year-old kidney molds, if you will. And when you take a look at what you can find in these caves, some of the more remarkable ones have a great history. And Rampart Cave is one of those. Rampart Cave at the western end of the Grand Canyon, 40,000 to 24,000 years and 13,000 to 11,000 years before present. And inside were all kinds of evidence of lots of different animals there, the fauna, the animals. And this is a list of just the mammals. And, porcupine, bighorn sheep, bobcat, a Brazilian free-tailed rat, Harrington's mountain goat, some of the things we'd expect today, but some of the ones, well, wow. The last one, yellow-bellied marmot, don't have that there, but we have it here in the Sierra Nevada at about, at my latitude, at about 6,000 to 7,000 feet. In the southern Sierra Nevada, about 9,000 feet. So that tells you how things have changed. We also had examples of some of the birds they were able to find there, and some of the reptiles that they have, and then protozoans they found in the sloth dung. Sloth dung, what is that? Well, it turns out one of the most famous fossils in Rampart Cave is the Shasta ground sloth. Now, ground sloths are found throughout North America. This one's one of the smaller ones at 9 feet and 500 pounds, one of the smaller ones. And here is something that Jim Mead also went down to Quaternary caverns and did the paleontology down there and found them there as well. And when you look at them, they, pretty remarkable animals. One of the other things they found besides the bones was their dung or their poop. And in 1938, they found hundreds and hundreds of their poops. And luckily for us, they were able to do all kinds of things to find out what they were eating, what were the plants, what might be the microorganism mixed in there, because not too long, well, I should say 40 years later almost, in 1976, some vandals broke through the lock gate, started a fire that destroyed 70% of the dung deposits. Because remember, it's vegetation. It's like burning peat in Ireland or carbon deposits some other place. So it just went up in flames. It's not all gone, but that was a very unfortunate thing. So when we take a look at putting it all together, and we'll come back and visit this fauna, we've got the Pleistocene, the Ice Age, we've got the late Wisconsin, where we are, the early Holocene, and where we are right now. The North American and the Southwest pollen data told us that we had a spruce woodland covering the area of North America south of the continental ice sheet, which makes sense. You know, we had ice there. Sorry, my dog's licking me over there, darling. My golden retriever. And 25,000 to 16,000 years before the present is the Wisconsin, which is the most recent glacial advance. And then it started to go back about 18,000 years before present. One of the cool things that came out is in White Sands, New Mexico, they have human indigenous footprints that they have dated between 21,000 and 26,000 years. And you go, wow, during a glacial ice age? Yeah. So they either came before and lived through the ice age or came down by boat and went cross country. It's neat to know the presence of human beings in the United States. It's much sooner than we realized. Large scale reduction with vegetation as things got to 10,000 years before the present. And now we've got this Pleistocene Holocene boundary where we are. And here things are starting to transition to what we have today. Narrow focus, let's look at the Colorado Plateau. We are going between wet summers to dry summers. Yes, we still have monsoons, but that's usually the southern Arizona area. The Colorado Plateau, which is raised up above that, is a little bit different in that it has this wet summer and dry summer transition. The middle Wisconsin with the mixed conifer forest, Caligony and Artemisia, which is our sagebrush that we have there. And then the late Wisconsin, again, our colder spruce and boreal or northern conifers are here. So you can see that things have changed. So early in fall, vegetation zones are lower, a decrease in woodlands, warmer and drier for today. And you look at the evidence, and some of that comes from the pack rat middens. And we know that the 47% of the species are present throughout. It's not like we wiped everything out to transition from one era to another, but a lot of them left because they couldn't handle it. The desert scrub, you know, in succulents, they survived a real long period of time. And then a whole depression of ranges. And part of that has to do in the Wisconsin with the presence of all the glaciers. To give you specific areas in the eastern Grand Canyon, besides Rampart, we've got Stanton Cave, we've middens there, yucca and cactus there, and 25% of the taxa is still in the river corridor today from that long ago. And you think of an accordion, when you open it up, has a wide top and kind of a V down at the bottom. So the high elevation flora have a greater vertical displacement than the lower flora, which moved hardly at all. So down at the bottom of the V, things didn't really shift or change. The river was the river. It still was kind of hot and not as welcoming or as changeable as the Tonto platform or even higher that we have there. Vulture Cave in the Western Grand Canyon, 30 to 8,500 years ago. Thank you, pack rat middens. Again, we have 28% was from outside, 50%, 7% still in the community today. And that tells you that if you still have some things that things in the past were eating, that animal population could still be around today. Shinemu Creek, Peach Springs in the Western Grand Canyon, longer area that we're able to look at. And they have woodland species, again, juniper and saltbush, and many from the Pleistocene have changed their elevation so that they could still be around because of the hotter. So what I want to say is individual plant reactions rather than whole communities shifted. And that came with some insights by Ken Cole that we'll look at in more detail in just a moment. So the Grand Canyon middens itself as an overview. We had displacements compared to today, and we went from, this is sort of a repeat of what we did, modern dominants began to invade, and each plant species responded individually. So it's not like we had a plant community like a boreal plateau community, and they all shifted as one. No, maybe this tree stayed and this tree left, or down at the platform, maybe this shrub stayed or that one left. So they all moved independently, forming whole new plant communities. And they weren't just depressed versions of modern tones. The composition changed over time. And then there's something called vegetational inertia. That means something's happened, the climate has changed, they didn't instantly stop and get replaced. So this inertia meant that there was 1,000 to 3,000 year lag between elimination of Wisconsin dominance and the arrival of Holocene dominance. So it was kind of like molasses shifting, not just as hard and fast shifting of different climates from place to place. So we had regions of plants dominance rather than a whole geographic change in there. And this particular direct ordinations shows you how in the full glacial you had spruce, mixed conifers, and juniper. You moved to the Holocene, and pretty much the spruce is moving out of the way, but you're saving some of the stuff from there, and the pinyon juniper. And then when you come up here, most of that's going away and things are shifting up, but you're keeping some of the stuff from before. So again, this is that vegetational inertia, and things taking a long time to shift. Nobody came up and said, we've got a new plant community, you're out, bud. They're surviving as best they can. Some of them make it, some of them did not. And this just gives you an idea, just looking at black and white and hatch marks, of how things have changed, but still stay the same. We still have representatives of the plant communities from some time ago to the present day today. Now, climate change, yeah, up and down and up and down and up and down. I don't think anybody questions that we're in a climate change right now. I think the big controversy came as to whether human beings were contributing to it or not. And if you want to talk about hot, go to the Permian. I tell you, that was a hot time, let me tell you. But the Pliocene, which is just before the Pleistocene, part of the Mesozoic, is coming out of glacial period as well. And you can see all the different changes that we've had over time. So changing, whether it's Milankovitch with the sun changing, sunspots, whether it's the rotation of the earth, whether we are tilted a little bit more or less, whether we had huge volcanic eruptions, which caused to put more debris in the air to block the sun, or millions of other things that can change our climate. Things changed. So again, climate is the statistical expression of daily weather events, what we expect to have happen. And just to review the proxy data, we have paleomagnetic reversals, radiocarbon dates, which are not very far, they only go back, for thousands of years, Heinrich events, Packrat middens, dendrochronology. And a little bit aside, David Douglas was an astronomer down at the University of Arizona at Tucson, and I was fortunate enough to have a fellowship down there and work with Tom Sweatman, and I got to look at the giant sequoias down there. But what I learned is he was looking at giant sequoias that had been cut down and looking at their rings to see if he could tell when the sunspots happened or not, if the rings of the tree show that. He really didn't find that. But what he did do was start the science of dendrochronology, an astronomer, and we use it in all kinds of things today. Marine oxygen isotopes, deuterium variations, which is a form of hydrogen variations in plant cellulose, and lake sediment cores. That's really important, especially for pollens. Here on the Mogollon Rim, we have the Potato Lake, and we also have Fracas Lake. We could look at pollen and microalgae. We found it was 7 degrees Celsius cooler in Wisconsin. It was dry in the Holocene here, near modern lake levels, but again, much warmer. And we also can tell that from marine isotope data. And when we look at, stage 3, stage 2, stage 1, we've got here isotope stage 3, isotope stage 2, and early and late, and then 1. And this just gives you an idea of how we're using proxy data, the isotope stage, to get a feel for how long ago something happened. We're not really looking at what happened. We're trying to find out what happened. Then we look at it and see what the changes were. So deuterium and cellulose is made by plants, fossil minerals from the Great Basin, which are to the north of the Grand Canyon, and a little to the west. If you go from the Sierra Nevada all the way to Colorado, that is the Great Basin. Full glacial, 3 to 4 degrees cooler, the mid-Holocene, 3 to 4 degrees warmer. So all of this proxy data is coming together and supporting each other. So we've got some really robust information. So Fracas and Bear Lakes, I have a map here in just a moment. We're looking at the sediments that are in there, cold and wet, early Holocene, middle. Again, they are just supporting each other on all the data that we're looking at. So the pollen is the circles, the clear circles. If there's more, then they become dark circles. Pack rat middens, less triangles, more larger triangles. And if they have a slice through them, there's no change. And lake levels versus they've gone up or not. And one of the cool things about the Great Basin era I remember looking at is there was the presence of limber pine in areas of the Great Basin where you have scrub and you have desert now, and you do not have those limber pines today. So we know it was much moister then. So full glacial with constant, we have much more rain that we had, a precipitation with its rain or snow, and it's 2.5 centimeters to the inch. So that's about 20 inches more. 24% higher in the South Rim, 41% higher than Phantom Ranches today, and much cooler today, 6.7 degrees Celsius. The early Holocene, similar to the Mogollon Rim today. We're up at 7,000 feet, 7,000 feet, a little bit warmer. Middle Holocene, greater evaporative stress, much warmer. And you can see from left to right, left is the most recent, and to the right, you could see the Wisconsin had a lot of changes because it was the glacial age. And so that tells you during the last 50,000 years, we've had a lot of climate change here. Caves and overhangs in the Grand Canyon. We have fossil arthropods, which are invertebrates with legs, 57 taxons of insects, arachnids, which are spiders, and millipedes. The late Pleistocene taphonomy. A word about taphonomy. I love taphonomy. Taphonomy is the study of how things decay. So if you come by and you see a roadkill on the side of the road, and you go back the next day, you can see instead of being a fresh deer all bloated up, the next day, something started to eat it and spread it around. The next day, it might just be skin and bones. And the next day, the bones are scattered, or the next week or whatever. So taphonomy is the study of how things decay. And I love our phrase. It's called where death is only the beginning. Mountain goat, camel, horses, ground sloth, teratorns, and condors. Teratornus was a huge condor-like bird, even bigger than our modern condor. These kinds of things we were able to study. Mammalian carnivores were scarce, skunks and ringtails. And then these animals bring bones into cave. And I did one of the carbon-14 studies of the condor bones in our caves here using carbon-14 and giving that to the Grand Canyon. And it was fascinating to see what was going on. And that kind of justifies bringing condors back, by the way, is we had them here historically or geologically. And so is it okay to bring them back? Bats and birds also in caves as well. Vulture cave, Basiriscus, which is the ringtail cat, we still have them. Many different pack rat middens that are there. And the Kern Association is not that different, only one species different from the past to the present. So those are some of the ones that hang on. The Shasta ground cloth, we already gave those dates. There's no dung in the cave of the coldest of the Wisconsin climate, and I'll show you why that might be. And it wasn't the glaciers that did it. They did become extinct during a time of ideal continued existence. What does that mean? Everything that we know from their dung that the Shasta ground cloth ate was still present when they went extinct. So some people have posited that perhaps it wasn't there in the abundance that they needed to sustain a reproductive population. I kind of like that one as well. And certainly when you go back, perhaps P.S. Martin's theory on people contributing to the demise of some of these short-faced bears and all these different things that were around horses and camels and stuff may well have played a role as well. Gymnogyps is also an ancient condor, Californicus. If you want to see them, they've got great examples, excuse me, in the George C. Page Museum down at Rancho La Brea. So remains are found in redwall limestone caves. Coincides with megafaunal extinctions. And part of that has to do with these condors are huge and they eat big things. When big things are no longer to eat, now they have to compete with the smaller vulturine birds that eat the smaller animals. And so we do know, for instance, California condors were called that because when the large die-off happened, they went to the coast of California where they could feed on whales. They weren't going to be able to compete with the black vultures and the turkey vultures that were eating the skunks and the rabbits and the other things as well. And we think that the condors might have come back into southern Arizona when the cowboys brought cattle back in. Now there's something big that's dead, condors can work on as well. So it's kind of interesting to see. So the reintroduction by condors is tenuous. You know, they have lead poisoning. I remember working with a biologist doing that. And because hunters shoot animals that they don't recover with lead bullets, that they would eat the animal, this is the condors, consume the lead and get lead poisoning. So in order to do a procedure called chelation of their blood, we would have to capture them. So we would take a dead rooster or something, put it at the end of a long dog run, and then they would find it, they would galump, galump, galump to the end of the dog run, get that animal, then we'd capture it, chelate it, send it back on its way. A very, very laborious process. And so one of the things that they're tried to do, and I'm not sure if they were totally successful, is try to get them to not use lead in the bullets where the condors are. But one of the biggest threats to especially the California condors is ethylene glycol at boat ramps. Where the condors are, they will lick the ethylene glycol, which is antifreeze, and that will kill them as well. We know, for instance, in human beings and dogs, the antidote is alcohol because the liver would much rather break down alcohol than ethylene glycol, and then the kidney gets rid of the ethylene glycol, saving their life. So if a kid came into my emergency room and had ethylene glycol, they drank antifreeze like kids tend to do, we would hook them up to an IV of alcohol until their ethylene glycol is out of their system. So I'm not sure that that's something we can do with condors, but that is a killer of condors. And Jim Mead, who moved from NAU to Tennessee, and I'm not sure if he's retired yet, but if not, he will never retire. He'll still be working. He took a look at the different animals that we have here, deafest tortoise, lizards and stuff, and what's gone. We don't have the Shasta ground sloth, horses, camels, or the yellow-bellied marmot, Oreamnos, which is the mountain goat, or Teratornis. There was no abrupt end to this, though. Some of them died and some of them persisted. So species reacted individually to changes in climate over the last 30 years, just as the plant communities did. It wasn't what cut them off, everybody died off, okay, the next population came in. So there was a lot of overlap. And it was pretty neat. So pre-glacial, post-glacial, and were slowly replaced by desert communities. And the woodland tax were gone by about 8,500 years before present. Speaking of human presence, I love the idea that split twig figurines have been in the caves for 220 million years above the Colorado River. If you haven't seen one, well, hang on just a second. I can see it. I've got a picture of one, but I actually have one that Phyllis Yoyotawa made for me. But they were dated at 3,500 to 3,900 years before present. That's a long time ago. Also, we have pictographs and petroglyphs. What's the difference? If you draw on a rock with something, paint, it's a pictograph. If you etch into it, then it's a petroglyph. They also have irrigation fields. I remember going up one of the side canyons of the Grand Canyon, and it's escaped me right now which one, and Tom can probably fill this in, but there are places where they actually have irrigation in, and maybe they cultivated yucca. And a lot of historical records, too, of people seeing that. So earliest historical records of climate in Egypt are 3,000 before the Common Era, China, and on and on. And to stop and think that our split twig figurines, and one of my favorite ones is ones with a stick that goes through it that shows that they were hunting them, are some of the best ones. So the influence of rock type on past and modern vegetation can hardly be ignored. Middens are restricted to the sandstones and the limestones, especially the limestones where caves can be made because of the rainfall that makes carbonic acid that makes the caves themselves and the speleothems themselves. And so little data from volcanic or metamorphic rocks because it would all be destroyed. So ancient lava flows have occurred periodically over the canyon rim near lava flows blocking the Colorado River in Grand Canyon. The most recent, and there may be more recent data than this that I have for us 140,000 years before present. So what happened is that resulting dam raised the level of the water in the Grand Canyon 225 feet. So any cave that had any middens in it was inundated with water and all washed away. And so anything at the western edge of the Grand Canyon was pretty much gone because of this volcanic lake that was made. So destroyed them, no lithic fossils, no Grand Canyon. So what do we got here to bring it all together? I know that was a lot of information, but changes in climate can be deduced from fossil vegetation. And of course, we have the dates from the proxy data. Reactions to fossil climate can be seen in the change in the faunal fossil material as they react to what they're eating. Topography, the lay of the land, including rock type, elevation, can affect the presence and preservation of fossil material. The easiest example I can give you that topography is we've got Doug fir on the south rim on the north facing slopes. They're not supposed to be there. So topography can influence what is there. And as climate changed, so did the flora and fauna, but they did so individualistically, not as communities. There was a lag where some hung on and some resisted, and we call that inertia. And changes are still happening today. And if you look at some of these great historic pictures, here's the Canyon of Lador, then and now. You've got a change in the river level, of course, and you've got a change of vegetation that's coming in. A lot of them are going to be tamarisk invasives. And then you look at Kanab Creek before and after. And, you know, it's just, is that really that much of a change? Is this some of that vegetational inertia that's hung on? So the north rim to the south rim, very different environments, but they all come together to make it a very grand canyon. Thank you for joining me tonight, Tom. That'll do it.
Wow, Nancy, that was absolutely lovely.
I'm going to stop the share so we can talk. Thank you.
Brilliant. Thank you. Thank you so much. I totally forgot to mention that attendees tonight should put their comments in chat during your talk. But after your talk, we're going to open this up to questions. And for you, I've got a couple before we open this up here. I just found it fascinating that Rampart Cave has marmots, which today, you know, are up in the high mountains at Timberline, maybe,
yeah,
and vampire bats, which are found today in southern Mexico and further south, where it's nice and warm. So I've always figured that those two species were not contemporaneous.
And they were not necessarily in this case. I just listed what they found there. They weren't necessarily there at the same time. I just made it easy by put it there. Otherwise, we'd be here 3 days.
But could they have been? Which is the interesting thing about species migrating due to predation. I just kind of wondered about that.
Well, you know, I was just in Brazil. I was in Brazil for 3 weeks, and they have vampire bats there. And vampire bats are incredibly successful. They just need a warm body to bite and lip the blood, and they're set to go. So if you stop and think, they're all the way down from Patagonia all the way up to Mexico today. And, you know, you can't help but think that could the population of large fauna decreasing and not having something in between for a while there because of man's presence cause the decline? Or did man just make a conscious effort to get rid of vampire bats? I don't know. But they have a huge range and they're very successful.
Fascinating. That's brilliant. Let's see, what else did I have? So what do you think happened to the Shasta ground sloth during the Wisconsin, this roughly 10,000 year period where they just weren't there, and it was colder, but the vegetation was there.
Right, but what I think, and there's a couple things that go on, is I really do feel that in order to have a population of anything, you have to have an environment with a carrying capacity to support it. And that carrying capacity has to do with that, that traditional triangle. You have to have enough vegetation to support the herbivores, to support the carnivores, and on like that. And if you have the same grasses, but it got so cold that the grasses started to die out, we're still picking them up in the fossil environment, but you've got, let's say, 500 ground sloths, and suddenly you only have enough vegetation because it's getting colder to support 40 of them, then 460 of them are not going to successfully reproduce. And in fact, there's also a truism that you have to have a certain number in a population for them to not be inbred to be successful reproducers. But also worldwide, 10 to 12,000 years ago, with climate change and everything else, something really remarkable happened amongst human beings, and that was agriculture. And we have evidence of some of the, and I hate to use the word Anasazi. Anasazi is a word given to the ancient people of the Puebloans that means ancient enemy. And again, Phyllis taught me a word called Hisatsunom. She goes, it's like people calling my grandparents enemies. She goes, my grandparents were called the Hisatsunom. And that's the word I prefer to use. So these people who were Hisatsunoms up on the plateaus on the North Rim and the South Rim who had agriculture, did they change it enough to make a difference? Did they hunt and have a predation pressure enough to make a difference? I don't know about here. It's possible, it's posited. I know it did worldwide in many places. And I would recommend a book called Guns, Germs, and Steel by Jared Diamond. Everybody should read that.
Absolutely. Absolutely. With that, I'm going to go down through the chat here and see what we've got here. Randy Roars says, many years ago, I was on a backpacking trip in a remote part of Grand Canyon, and someone's trekking pole went missing overnight. We couldn't find it. 2 years later, a person on our trip returned to the area, poked around, and found the missing trekking pole. It doesn't
That is amazing.
Make sense. Tough.
And to add to your pole story, I'm a Pacific Crest Trail section hiker. I've done 2008 miles and I'm still working on it in sections. And we all have trail names. Mine's RoboDoc. But the best trail name I ever ran into was a guy with 2 trekking poles, held them up and said, well, my name is Bipolar.
That's very good. That's very good. Karen Greg, you put in cultivated agave, and that was when Nancy was talking about irrigation in some of the drainages that have water. But also, I think maybe as Karen was pointing out, cultivated agave includes terracing.
Yes.
Basically,
is it Deer Creek I'm thinking of, Tom? Because I went up there with somebody.
It was, yeah, because you had said yucca, but it was agaves. Agave phillipsiana. So
okay.
They're at Deer Creek.
Okay, and, then my mistake to put yucca instead of agave.
Yeah, and
yes, there was terracing there, and I will go right in there and change that and apologize for that.
It's okay. They're also in up Clear Creek and also up in Upper Phantom.
Excellent. Excellent. Thank you for that.
You're welcome.
Very cool. And with that, let's open this up. Let's see if we unmute all. Let's see if I can do this. I just asked everybody to unmute. If you have a question for Nancy, you can simply unmute yourself and bring that question forward. Please feel free.
For those of you interested, my background is the Northern Lights I took from Greenland. So, and the picture doesn't do it justice because they were dancing.
Oh my gosh.
How can I help you? Or comments?
Nancy, this is Mark Braden.
Hi, Mark.
Hi. Can you explain the difference between the breakpoints between eras other than extinction events and glacial events?
Not really, because it is, if you look at a really detailed geologic time chart, they have, minute things. I have one, but I don't have it to show it to you now. They look at those things, the true geologist. And, you know, I am not what I would call a true geologist. I'm more of a paleontologist. And, you know, you can go all the way down to the Younger Dryas and you can go all these different places. But even in that area, they divide it up into, you know, little sub areas as well. So that is beyond my knowledge. But almost all of them are based upon events that they can denote in animal or plants. So we've got the Devonian, you know, the era of fishes, and you've got the Precambrian, and you've got all of the different Burgess shale single-celled, not single-celled organisms, but soft-bodied organisms that were remarkably preserved there in Banff National Park. And then you can go up and you can see, you know, during the Mesozoic, the Jurassic, Triassic, Cretaceous, you know, and everybody loves that because that's the age of dinosaurs. But even within there, there's probably 50 different divisions within there that they do based upon a fossil they found here and supported it over there. And that's beyond my ability, but I do know they divide it up a lot.
Okay. One more question. What does paleomagnetic reversal have? How has that affected plants and animals?
That's a really good question. For those of you who've never heard of paleomagnetism, we do have an Earth that has semi-solid. 3 days ago, they decided it wasn't a solid iron nickel core, but it was semi-solid. But anyway, we have an iron nickel core, and out of that, the outer core is liquid, and then we have a mantle that's mostly solid, and then we have an asthenosphere, which is just underneath the crust of the Earth. And so if you take a look at the Earth itself, we have the movement of electrically charged particles, which is what you need to have a magnetic field. So that area where it's liquid has that. If you go to the moon and you take a compass, it's not going to do you any good. The moon is a solid ball, and it doesn't have any part that's liquid. And so, of course, individual metals may have an electric field in themselves. But in order for the planet to have a magnetic field, which is protecting us, thank goodness, from all kinds of things, then you have to have the movement of electrically charged particles. There are as many theories as to why and then you have this liquid rock coming up that has a magnetic field, and then when it hits close to just underneath the crust of the Earth, then it solidifies because it's cooled down, and it solidifies at a particular angle like this. And trapped in that angle is the bipolarness of that magnetic field. Well, they have noticed that every 13,000 years, 30,000 years, depending upon the data, that instead of like this, now it goes like this. And now it goes like this. And they're able to date things because they can date the different rocks and the volcanic rocks that's holding them. One example is potassium argon dating. If you have a volcano that spews up into the air, and as it spews up in the air, it grabs the air as it goes by, and that little hole is forever trapped in that volcanic rock, which is why pumice likes to float, for instance. It's got more air than rock. But you've probably seen volcanic rock with cavities in them called vesicles. We could take that volcanic rock, put it in a machine, cut it open, and measure the ratio of potassium to argon. We know the half-life, and so that can tell you how long ago that happened. So we know how long ago this switch of the paleomagnetic field happened. Why it happens, many different theories. We just know that we have a reversal of North Pole to South Pole and South Pole to North Pole. And I can't tell you anyone that I personally believe in. So I will leave you at that it exists. Why it happens, I don't know. And I don't know anybody that has enough data to tell you why.
But does it have any effect on the environment?
On the environment, I don't think so. The important thing about the magnetic field that we have that envelops the Earth is it protects us from cosmic rays. And
Right.
Cosmic rays is a fancy name of saying neutrons, neutrinos, positrons, electrons, that if they came through our body would hit our molecules, smash things apart, break us apart, cause cancer, and we wouldn't exist. Is it possible during that flip over that there's a period of time that we don't have that protection? Absolutely, that would create some havoc. But I haven't heard any evidence that has happened to it. But I think it's possible, unless it's a real smooth transition, which I don't know anything about. I'm sorry.
Okay.
Hope that helped.
Hmm.
Anybody else? Questions for Nancy? Well, what I'm going to mention, I got a little side note from Jonathan Upchurch. Jonathan's a brilliant guy. And Jonathan just said, Tom, you know, there's this history symposium coming up on the 1st, 2nd, 3rd, and 4th of November, and there's still 50 seats left. If you haven't registered for this history symposium, man, you better get on it, because we are expecting that to be sold out. And there are just so many incredible presentations happening. So that's coming up. Any more questions for Nancy? And if not, Nancy, thank you so much for being
You're
with us
welcome.
tonight. I do want to mention that a month from now, same time, same place, at 6 o'clock, Tuesday, November 14th, archaeologist Ralph Brillo will be presenting the anthropology of paleontology, and we hope to see you then. With that, I wish you all a very, very good night, and we'll see you next month.
Good night, everyone.
Good night.